All right. So we're going to be looking at 4.5. We'll go through this pretty well. 4.5 starts talking about residual and residual plots. So a few things that we want to just cover, make sure we're okay with. So correlation we've been dealing with. That's your R value. And this tells you your strength of your ordered pairs, can be positive or negative. So correlation, if your correlation of your R value is greater than 0.7, it's considered strong. If it's between 0.3 to 0.7, this is moderate. And if we have R being less than 0.3, this would be weak. So this is, again, when you plug into your calculator, you get the R and the R squared value. The R value is going to tell you how strong your data really would be. Okay, so that's the first part. So the only thing different from that is we have not added, we've talked about this somewhat, just verbally, we haven't really put it in writing, so now that's more of it in writing, okay? The next thing is interpolation. So if you were to plot data, you had all of these plots, these dots on here, you had your line of best fit drawn. If I select to get something between those 2 points, it's called interpolation. So it's inside your data. This is usually pretty good to make an educated guess off of, or to make a judgment call of. So interpolation is inside the data, and then the other term is called extrapolation. Extrapolation is if we had our data plotted, we had our line of best fit. Inside here to here would be interpolation. Outside of here or outside here where the data doesn't exist, but the line of best fit might fit, is called extrapolation. And a lot of times with extrapolation, in order for this to work on the calculator, you'll have to zoom out on your graphing calculator. And the reason you want to zoom out is because a lot of times when you extrapolate your data, your window's set up for your data, the line of best fit is drawn in there. The extrapolated point is outside that data, so it's not fitting in your window. So if you try and do a line or try and do a guess by extrapolating, by plugging it in on the calculator, it's outside of what the window is, and the calculator is not smart enough to realize that something exists outside of the window right now. So zoom out. It's going to make your data look a little bit smaller. It's still all good stuff, and then you can plug your value in. Okay? So this should all be relatively new or normal stuff. You know this stuff. You've heard this stuff before. And the newest thing that we're going to talk about is called the residual. Okay. And then it's going to be observed minus predicted. And so this is like an actual point or piece of data, and this is your y hat. So this is what the calculator came up with. Okay? So a residual is going to tell us what's our data doing. So we have the R that says, hey, if it's above 0.7, it's good data. The residual is just another tool that we could use in order to do it. A residual graph looks a little bit different than your plotted graph. And I'm going to show you how you get to this. But a lot of times, the residual graph might look something like this. And how this is working is you have these distances. And so some of the distances are negative and some of them are positive. And then some of them might be spot on. Wait for the camera as you go by. Nope, that way.
Pretty smart.
I like it. So, what we're going to do in order to find the residual is you take each of these distances, whether they're positive or negative, and you add them up. Sum up the distance. If it comes out to 0, that's going to tell you that your line of best fit is pretty darn good. Okay, it's going to tell you you have an R value that's above 0.7. If your residual value is positive, if you have a positive residual value, meaning you've added all of these up and it's positive, that means that your line of best fit underestimated the data. Okay? So that's going to do this. If it was positive, this would be our line of best fit. And if it's positive, that means that we have more points further above our line of best fit than below it, so we underestimated. And then if my line of best fit, if I sum up all my d values and it comes out to be negative, that means our line of best fit's here, and more of our distances are below, so we overestimated our line of best fit. And of course, your calculator's doing the work for you. So what are some things that you think that might be happening wrong with your data? If I underestimate or I overestimate, your calculator's doing the best it can with the data it has. If I underestimated, do you think we have a good R value? What do you think? I'll tell you the 0 residual means that we are going to have an R value that's greater than 0.7. So if I underestimate, our R value is going to be less than 0.7. So it's moderate to weak, depending upon how far it is. Okay? So I want to work through one, and it's going to take a little bit of time to go through it. It's not horrible, but a lot of times when you are looking for things in math, especially statistics, is you want to know, is your information good? Unfortunately, they throw it out there. When I say they, I'm talking news organizations, I'm talking about government organizations, I'm talking about any organization that has information that wants to influence. A lot of times they're going to ignore R values and residuals. Okay? Again, it's so easy for you to find a study you're going to agree with. Okay? There's a study being done that's been done a couple times, and they want to raise the driving age to 21. You guys don't like that. Why? Yeah, you wouldn't be able to drive. It affects you. So a lot of times, you, being this population that's younger, will look at something like that saying, well, if you're going to wait till I'm 21 to drive, that guy who's like 70 sure has no business being on the road either. What's the problem with the young population versus the old population? Any ideas? Let's go a little social studies. Why? I like it. Young, don't vote. What are some other things that are wrong with the young population? Who is the young population often influenced by? The older population. So you are brought up. How you doing there, Cupcake? Thank you very little. She's not here. A lot of times you were brought up, and you probably have a lot of the same thoughts as mom and dad. You have a lot of the same beliefs as mom and dad. As a teenager, you will rebel somewhat against mom or dad. And then as you progress a little bit older in life, you'll start realizing that mom and dad actually are relatively smart people. And as Mark Twain said, from age 16 to 19, my parents were the dumbest people on earth. And when I was 30, I was amazed how much they learned in 12 years. Okay? So the young don't vote. And if they do vote, they are influenced by the older population. Perfect example. I'm going to rip on a school district I used to teach in, Douglas County. Okay? So Douglas County has got a great sales pitch for brand new teachers. It seems like a pretty good place to teach as a brand new teacher. Because if you are a math teacher, they'll bring you in, they could bring you in about 10 grand higher than first year teachers in other school districts. That sounds pretty good. We're enticing you with money. Hey, young folks, come on down here. We have a world-class education. In fact, that's going to be our motto of ours. And so you get this brand new teacher comes out of school who's been indoctrinated through psychology classes and philosophies of education, and they're like, I'm going to change the world. Everybody's going to learn math from me. I don't know what's wrong with these older teachers. What the heck? There's kids that are failing. What's wrong with that older teacher? I'm going to change the world. Hey, you know what? They could pay me up to this much more. In fact, we could say that a hard-to-fill position that is classified as a highly effective teacher, which is our highest rating, could earn $20,000 more than anywhere else in the state. That sounds good. So you're getting that teacher, starting income for a teacher in most of the Denver suburban area teaching places is probably about $35,000, $36,000. Okay? I know it doesn't seem like a lot, but you know, a lot of times people get into teaching realizing this is what I'm going to do if I live within my means. If I don't watch the government and how the government works and I live within my means, I got a pretty good life. Government doesn't live within their means. They're spending someone else's money, which is really easy to spend. But then I'm going to start looking at this going, wait a minute. Okay, so I make $35,000, $37,000. I can make like $45,000? And heck, they're claiming I can make up to $55,000 this year? I'm in. I'm in. Heck yeah. Love it. Things that they don't tell that new teacher. This is the metaphorical carrot. Come on, you get that. Come on, work a little bit harder. Come on. Oh, look how close you got. You're almost there. I realize you gave up 15, 20 hours a day to try and get, you were so close, but we're really sorry. You didn't quite get there. Here's some things that you could try to work on to get you here. Sound good? No, you'd be pretty pissed off after that first year. Oh, wait a minute. I got a friend that got a job in Cherry Creek School District, and though It looked like I was going to make a little bit more. And it looked like, man, I could really make more. And I'm going to go and have dinner with my friends going, dude, I can make this. And the new guys at Cherry Creek going, wow, that doesn't seem too bad. What does the veteran teacher do? The teacher of 10 plus years do? They look at Douglas County and say, you guys are full of a bunch of malarkey. In fact, I was making right around 70, and their salary band went up to 55 for math teachers. Went from 35 to 55. See, this is how they lure you, saying, hey, new teachers, you can make anywhere in here. Sounds good. I love it. So they told me 5 years ago, well, this is what our salary band is. This is what you're making. It doesn't matter if you're partially effective, effective, or highly effective. You'll never get a raise there, Chris Stirrup. Oh, gee, this seems like a neat place to stay. And then they changed it a little bit and said, in fact, what we'll do is we will start rolling you back so we can get you within this range. And so I said, sounds like a pay cut to me. Oh, no. That's the business model. That's how it works. No, it sounds like a pay cut to me. No, please don't think of it that way. It's not a pay cut. No, it's a pay cut. Chris, listen. You do great stuff with kids. It's just that, we could hire 2 new teachers for what we pay you. It's called the Walmart effect. Hey!
How's it going?
Doing well.
This student?
Yep, he's right there. He's a good kid. I kind of played with matches earlier, but it's okay. We burned them all up.
All right.
So what are things that I knew as a veteran teacher to do? Yeah, that's why I'm sitting here. I will tell you that opening a medical class at Chaparral High School many years ago was fantastic. There was a lot of really cool stuff that was taking place. And then the school district got greedy, and they started looking, going, look at this med class this guy's got. He's got 100 kids from 8 different high schools that come in the morning for this class. So they started charging the state, and I was making the district money by offering the med class. And then they said, no, we'll roll you back. And it doesn't matter how hard you work, pal, you're already making way above our salary cap, so you'll never get a raise. I don't know about y'all, but it didn't seem like really good incentive to stick around. Come to this district, pretty good. Darn content, and you guys are the greatest kids in the world. Way. So, young don't vote. When they do vote, they're influenced by the elders. Why do the old people vote? Because they understand the power of the vote. The old people don't have anybody any older than them to help them out. So they don't have elders. And why would I listen to some punk kid about my vote? So, influence of data. Young don't vote, young do vote. I'll just tell you this, guys and girls. Street corner politics is easy and fun to listen to. It's called gossip. Watch out for it. Okay? Learn the facts about when you do cast your vote, and don't be the person going, oh, my vote doesn't really matter. That's the old people talking. Hey, kid. You ain't ever going to get what you want. So don't even worry about voting. Be all right. I just caught another 18-year-old person not to vote. So now my vote's even better. And the AARP, the Association of Retired Peoples, they get it. And they get their way. Because they all get together and they get these mailers saying, hey, vote for this guy, he's doing this. All right, guys, come here. Beverly, Ruth, bring your husband over. I know he's not on oxygen. Bring him over. We're going to vote this way on this, okay? Sounds good. Why did Douglas County do that? Over 60% of the households in Douglas County do not have kids in public education any longer. They're empty nesters. Their kids are in school. Put the phone away. So why did Douglas County turn to that? Hey, I realize you have kids in school and things seem bad. Don't worry about your vote. It's not going to matter. Hey, 30-something-year-old people, don't worry about your vote because it doesn't matter. Us folks here in Douglas County, we know what we're talking about. So by them doing that model right there, guess what happened? Taxpayers save money. Old people don't have to pay. Old people don't have to pay. Those demented folks down there live in the 6th richest county in the United States. And they don't want to pay for public education because why should I pay? Here's the reason. If you don't ever hear anything from my class ever, is this. Your vote matters, and continue to push for public education because public education is the whole foundation of America. We will educate our people so our people can better themselves. You have people that say, I don't need this education. I got it. My Uncle Louie, he sits around and sniffs glue all day and he's a millionaire. Yeah, everyone's got a friend that, or an uncle that, or an aunt that. But it's not 100% of the population, so don't fall into that. So let's talk about this residual. What is it? So a residual plot is going to look like this, like we talked about. A residual plot, let's talk about Sarah's parents are concerned that she seems short for her age. Poor Sarah. Poor old Sarah. I think I can do this. Let me plot this on the calculator quick. All right. Yeah. Stat, edit, clearing up the data. Oops, I just figured out this data. 86, 90, 91, 93, 94, 36, 48, 51, 54, 5, 17 times. Oops. 36, 48, 51, 54, 57, 60, 86, 90, 91, 93, 94, 95. All right. Let's see. Y equals. Let's clear out that. I don't need this garbage. So I'm going to go zoom 9. That's our data. Looks linear. Let's find what our y hat will be. Okay. So one tool to know that we have a good line of best fit. R. R pretty good? Yeah. 99.4. Yeah, 0.994, so it's close to 1. So our data is looking good. So that was one tool we're going to use in order to verify that we have a good line of best fit. R 0.99, R squared 0.98887. Our variance is 98.87%. So remember, your variance is your R squared. Okay, so I'm going to go y equals vars, statistics, equation, graph, and I draw this line of best fit. So things I want you to recognize. Does this piece of data appear to be a little bit above or below our line of best fit? What about this one? That? There? There? Right on it. Okay? So we have, I bet you we have a pretty close residual value of pretty darn close to being 0. Is that okay to say? All right, so let me do this. I'm going to go back here real quick. Let me plot. Let me talk about these. So list 1, list 2. So I have 36, and that yields me 86. 48, 90, 51, 91. I'm just plotting my data. 54, 93, 57, 94, 60, and 95. Okay.
You can drag your graph from the calculator onto there.
Are you kidding me?
No. Zero to zero.
Really?
Yes. Make it small squares. So
What?
Which one is the top right corner? Nice and X. You make a small window. Yeah. Do that.
That?
And then move it over. Drag. Not the big one. The regular size. Move the move.
Do it for him.
This one?
I can do it.
Oh, uh-oh. You're going to hack into our system now.
I'll make it easier for you.
You're so cool. I love this.
Straight. Oh no. Give us a stroke.
Love it, dude.
And then bring it bigger again.
Woo!
Oh. Is that helpful?
Yeah, thank you. Dude, sweet. All right.
That's good.
Move it up.
No, it's not there. Let's rotate. Go to the next square. Yeah, there. You move it all around. Move it along.
Perfect.
So you don't have to draw it.
Sweet. I love it. Thank you, sir. All right. So now I want to do this as well. Okay.
Square and drag.
I can just do this.
Yeah, you got this strip. Yeah. Make it bigger. Bottom. Yeah.
I mean, Winston, you're the coolest kid ever. All right. Oh, this is so cool, dude. Newest toy ever. Dude, that's so cool. All right. So, so we are getting this. We are getting this information from plotting in. So now what I want to do is I want to actually plug 36, 48, 51, 54, 57, and 60 into our equation. So we can easily do that. Will someone just jot this down real quick? Or you can plot it in a calculator. All right. So, graph, there's your line of best fit. So I want to know what the value of 36 is. So the value of 36, I'm going to go second, calculate, value 36, enter, and that gives me 85.75. And I'm going to actually put this in L3 eventually. Okay? And then I want to find the value of 48. So same thing. Second, calculate. 40, whoops. Second, calculate. Number 1. 48. Enter. So 90.35. Yeah?
So are you finding the difference, how far off you are in the second list?
So then I'm going to say second, calculate a value. I'm going to plug 51 in. So I'm finding our line of best fit and how far off our data was in order to make that line of best fit. 91.5.
Could you go back to how to find the line of best fit one time? Let's go back to the steps you did well.
Line of best fit?
Like just like how you got to the original graph.
Okay. So I had to go stat, calculate, linear regression. And once I do that, then I go y equals vars. And then when you hit vars, you go down to statistics. And then you go over to equation, and your regression equation's right there. And that way it'll plot it onto your graph. All right, so let's find 54. So second, calculate. Value, 54. So 92.65. Plug 57 in. $93.8. Then plug 60 in. $94.95. Okay. So what are some things that I know about each of those pieces of data? They're not that far off. Are some of them, so remember, I went back, slide here, observed minus predicted. So this is the actual versus what our linear equation says. So our observed, our observed is from our table. Our predicted is when we plug it in. Okay? So observed minus the actual. So 86 minus 85.75. And I'm going to put the sign with it. This will be positive 0.25. What does that tell you about the line? Are we above it or below it with this? Above it. Just a smidge above our line. Okay? And then this one is going to give me, I'm going to go this minus this. So that's going to give me negative 0.35. So am I above or below my line of best fit? Just a little bit below it. And then I'm going to subtract these, and I'm going to get negative 0.5. Am I above or below it? Just a little below. I'm going to subtract those. I'm going to get 0.35. That's positive, so I'm a little bit above this line. And then I'm going to subtract those, and I'm going to get positive 0.2. So that's a little bit above it. And I'm going to subtract those, and I'm going to get negative or positive 0.05. So I'm a little bit above it. So if I add those values together, being positive or negative, so 0.25 minus 0.35 minus 0.5 plus 0.35 plus 0.2 plus 0.05, enter, 0. So if this is all summed up, it comes out to 0. Remember our R squared value, or our R value on this was pretty high, it's like 0.99 something. This is verifying that we have really good data. And if we wanted to visually see what this is doing, I mean, the closer these get to when I sum them up to 0, the better our data is. So let's do this. Let's go under our plots. I'm going to stat. I'm going to edit. And under list 3, I'm keeping list 2 and list 1 there. It's the same. But I'm going to go 0.25. I'm going to go negative 0.35. I'm going to go negative 0.5. I'm going to go positive 0.35 or just 0.35. I'm going to go positive 0.2. Positive 0.05. And now what I want to do is I want to graph these. So I'm going to get rid of my y equals. I don't want my line of best fit there. I'm going to go back into stat plot. I'm going to still use number 1. But I'm not going to have list 1, list 2. I'm going to do list 1 and list 3. And I'm going to go zoom number 9, so zoom stat. Oops, put out there. So zoom 9. Take a look at our data. Here's above and belows. So all of these distances, so the distances from here and here are negative distance. This is a positive distance. This perhaps is just barely positive distance. But if I add up all the distances on top and all the distances on bottom, they sum up to 0. That's going to indicate that our line of best fit's pretty good. If this value becomes a positive number, that means our data is more above our line, so our estimate or our line of best fit is an underestimate. If our line of best fit is below it, it's an underestimate. Okay? Overestimate, yes. So, all of those equals 0. This is a good estimate. This means this line here is underestimating our data. And if I have it like this, so our summation is going to be a negative value. That means I overestimated my line of best fit, and that's what the calculator did. A lot of times that underestimate, not overestimate, have taken place because outliers have taken place in our problem. So some whacked out, way off the chart numbers, our line of best fit is going to fit in there. Remember, when we look at our R value, the closer that is to 1 or to negative 1, the better our line of best fit is going to be. But then if we have something way positive, we're underestimating, or we have some outlier that's way above the line, if we sum them up and we get negative, then we are underestimating our line of best fit. And that's what it's going to go with. So, I want you to try if you will, do the best you can on this. Let's do 4.5 worksheet. And a lot of it you're going to be able to do pretty quickly. It looks like 10 questions. But I'm going to give you a couple minutes. You've got about 6 minutes to start on it. And this is all it deals with. Okay?